Your coding bill just hit $1,500 for the month, and the model that cost a tenth of that, Gemini 3.6 Flash, was sitting right there while you were running Kimi K3. Kimi K3 is built for peak coding power, Gemini 3.6 Flash for cheap speed, GPT 5.6 Terra for the premium middle. So the real question is, which one do you actually ship with? Test 1, Coding and Agentic Benchmarks. The day your model fails a real SWE task, you're not just losing time, you're shipping bugs or rolling back a deploy at 2 a.m. Goldie Bench ran 50 fixed tasks, SWE Bench tested real GitHub issues, and Front-End Code Arena scored UI generation head-to-head. These numbers tell you who actually writes working code. I looked at every score across the board, and Kimi K3 came out on top with 7.89 out of 10 on Goldie Bench versus Gemini 3.6, Flash's 7.08, and GPT 5.6, Terra's 7.45. And on SWE Bench, Verified it reported 76.8% against Gemini Flash's community measured 68.9%, though one's vendor reported and one's community measured, so treat the gap as directional rather than definitive. Now, the SWE Bench gap mixes vendor and community numbers, so I'd treat it as directional, but Kimi K3's Goldie Bench lead is independently scored across 50 tasks, and its front-end code arena rank of 1679. ELO, sitting at number 1, makes the coding win pretty hard to argue with. Kimi K3 takes test 1 on coding benchmarks, and the safer pick here is clear. If raw coding output quality is your downside risk, Kimi K3 is the model where being wrong costs you the most. That puts the score at Kimi K3 1, Gemini 3.6, Flash 0, GPT 5.6, Terra 0. I've been living inside these APIs long enough to catch the gaps the docs don't mention, so let me know in the comments if the benchmark gap here has already burned you. Test 2, API pricing and cost per query. At 500 million input tokens a month, the wrong choice here doesn't cost you a few bucks. It costs you over $1,000 in a single billing cycle. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Fresh input tokens, cached input tokens, output tokens. All three pricing rows are on screen right now, and the spread between these three models is genuinely wild. Watch what happens when you line up the numbers. Gemini 3.6 Flash charges $0.30 per million input tokens versus Kimi K3's $3 and GPT 5.6 Terra's $5. And on output, it's $2.50 versus $15 versus $20. So at 500 million tokens a month, that's $150 for Gemini Flash against $1,500 for Kimi K3, a straight 10 times difference on the same workload. Gemini 3.6 Flash takes test 2 on cost, and the risk framing here is pretty simple. The downside of picking wrong is a monthly bill that's 10 times bigger, which isn't a rounding error you just absorb. That ties it up at Kimi K3 1, Gemini 3.6, Flash 1, GPT 5.6, Terra 0. Test 3, response speed and latency, 180 tokens per second versus 1 or 10. That gap sounds small until you're running an agentic loop that calls the model 40 times, and every extra second compounds into minutes of wall clock, wait time your users feel. A slower model in a coding agent is the kind of thing people notice after about 2 days of use, and then they stop reaching for it. I had to run this twice because the gap is bigger than I expected. Community measurements from artificial analysis put Gemini 3.6 Flash at 180 tokens per second, GPT 5.6 Terra at 140, and Kimi K3 at 110. So Gemini Flash is 64% faster than Kimi K3 on output speed, and for interactive coding, that latency difference is something you feel on every single response. Gemini 3.6 Flash takes test 3 on speed, and the safer pick is the one that won't leave your agentic pipeline sitting idle, waiting for tokens to trickle in. That moves the score to Kimi K3 1, Gemini 3.6 Flash 2, GPT-5.6 Terra 0. So Kimi K3 is winning the quality game but losing cost and speed, and that raises a real question. What happens when you look at output limits and deployment options? Because if Kimi K3 can't generate enough tokens per response for your actual workflow, or if you need image input, the whole picture shifts. And that's exactly what the next two tests are going to tell us. Test 4. Context and output limits. 16,000 output tokens sounds like a lot until you're generating a full module with tests and documentation, and the model just stops mid-file, and now you're stitching together multiple calls to get one complete artifact. For agentic coding workflows that generate whole files in one shot, the output ceiling is the constraint you hit before anything else. All three models match on context window at 1 million tokens, so no winner there. But on max output, the spread is real. Gemini 3.6 Flash goes up to 65,000 output tokens, GPT-5.6 Terra sits at 32,000, and Kimi K3 caps at 16,000, so Gemini Flash's output ceiling is 4 times bigger than Kimi K3's, which matters a lot when you're generating long code files in one pass. All three share the same 1 million token input window, so on context ingestion, this is a complete draw. But the output limit is where Kimi K3 genuinely falls behind. And if your workflow regularly generates files over 16,000 tokens, you're forced into multi-call stitching that adds latency and complexity on top of an already slower model. Gemini 3.6 Flash takes test 4 on output limits, and the downside of picking Kimi K3 here is real. A 16K output cap on a model that's already slower means you're paying more and waiting longer just to get a truncated file. Score now: Kimi K3 1, Gemini 3.6 Flash 3, GPT 5.6 Terra 0. Test 5. Deployment and modality. You build a coding agent that needs to read a screenshot of a UI bug, and then you find out the model you picked is text only, so you're rewriting your pipeline or adding a separate vision model just to handle one input type. Modality support and open weights aren't features you think about until they're the thing blocking your whole workflow. When I looked at the deployment specs, Gemini 3.6 Flash and GPT 5.6 Terra both accept image input alongside text, while Kimi K3 is text only, so 2 out of 3 models handle multimodal inputs and Kimi K3 doesn't, though Kimi K3 is the only one with open weights released July 27, which is a genuinely unique advantage if self-hosting or fine-tuning is your actual use case. Gemini 3.6 Flash takes test 5 on deployment and modality, and for most API users, the safer pick is the one that doesn't force a pipeline rewrite the moment a screenshot shows up in your inputs. Final score: Kimi K3 1, Gemini 3.6 Flash 4, GPT 5.6 Terra 0. Kimi K3 wins on raw coding benchmark performance, 7.89 out of 10 on Goldie Bench and 76.8% on SWE Bench verified. And it's the only model here with open weights, so you can self-host it, fine-tune it, and keep your data off third-party infrastructure entirely. If you're building UI generation specifically, its 1679 ELO ranking at number 1 in front-end code arena is pretty hard to beat. Gemini 3.6 Flash wins on everything that affects your daily running costs and workflow speed. It's 10 times cheaper on fresh input tokens and 6 times cheaper on output. It runs at 180 tokens per second versus Kimi K3's 110. Its max output is 65,000 tokens versus Kimi K3's 16,000, and it handles image input out of the box, all without sacrificing enough quality to matter for most everyday coding tasks. GPT 5.6 Terra sits in the middle on every axis. 7.45 on Goldie Bench, 140 tokens per second, 32,000 output tokens, and image input support, but at $5 per million input tokens and $20 on output. It's the most expensive of the three, so it makes sense if you need OpenAI's ecosystem and tooling and you're willing to pay a premium for that integration. If you need peak coding benchmark scores or you want to self-host on open weights, Kimi K3 is your pick. If you're running everyday coding tasks at scale, Gemini 3.6 Flash wins. And at 500 million tokens a month, that's $150 versus $1,500. So the only reason to pay 10 times more is if the benchmark gap actually shows up in your specific output. One thing the pricing page doesn't make obvious Kimi K3's advertised 0.60 per million input tokens is a cached context rate, but on a cache miss through the Moonshot API, you're actually paying $3.0 per million, which is 5 times higher. And most fresh API calls in a new session are cache misses, so your real cost is almost never the headline number. If you want to see how Kimi K3 holds up against another strong open weight challenger, I already ran the numbers in the Kimi K3 versus DeepSeek V4 Pro versus GLM 5.2 comparison, and the pricing story there is a completely different kind of wild, so that one's worth checking out next.